This is a brief demonstration of the Brain Avatar Brain EEG mapping system. What you're seeing on you now is a clinical 19-channel recording similar to the same one done for epilepsy or other neurology disorders. This is all done with software rather than the old-fashioned pen and ink GAS JSS polygraph system. And this is running in real time, replaying. These are maps that show brain electrical activity. Not all that interesting, but they're from the BrainDX database from NYU. This is real-time Z-score mapping, either absolute power at the top and relative power at the bottom for the bands of interest from delta, theta, alpha, beta, gamma, and all of the 19 channels. There's Z-scores looking at a normative database such that 0 is the exact average and plus or minus 1 is one standard deviation. This is a way of looking at Z-scores from a region of interest. These are all the region of interest over here. The different anatomical areas of the brain that are mapped out from large areas such as the frontal lobe, or small areas such as the anterior cingulate gyrus, cuneus, medial frontal gyrus. Now we're getting to some interesting areas in which we're looking actually at a three-dimensional brain electrical activity mapping by ROI region of interest. This is Brodmann's area 21. Go back up here. And what you find over on the left is a description of the area in terms of its responsibilities and what happens with deficits. This is the front of the brain, and then we're going to rotate it. Here's top down. This is the division between the two hemispheres. This is where they're joined at the back of the corpus callosum. Rotate again to a lateral view. And the nice thing about this is that we can look at different areas by Brodmann's area, such as this is the posterior cingulate gyrus. And it reflects in real time also the Z-scores, with this nice green being 0 and then down to blue with -3 Z-scores under activation versus 3 D-scores over activation. Or we can change from a Brodmann's area to an anatomic area, such as here's the frontal lobe firing. So with this, I'll go all the way from old-fashioned squiggly lines representing the different brain waves, alpha, beta, theta, delta, to maps, to surface mapping of Z-scores, to Brodmann's area of analysis. And when you come back, you lose all the verbal descriptions on the left. But basically, these are at a value of maybe 5 to 7 voxels or less, and may have a 30 millisecond delay. So there's almost real-time brain electrical mapping of cognitive activity. There's a ventromedial frontal lobe, and we're 45 near the speech areas. There's Broca's area. So it's just a brief demonstration. The next part of this, rather than just recording, is actually feeding the signals back to people through a visual display and helping them change their frequency or amplitude in that frequency band relative to other ones.